All right, how is everyone?
Not too bad. How about you?
I'm doing okay. Well, our plan today is to talk about sockets in Java a little more and complete the client side of server-client programming, and then tie that into PA5, go through some more detailed pseudocode on PA5 to figure out how we're going to use, a thread and all of this networking stuff to make PA5 a networked game. And then I'll talk a little bit about other aspects of doing networked communications beyond what we're doing in PA5. So some of the complications and resolutions that come up with more complex examples of communication. So let's start with any questions on the programming assignment or other stuff. All right, well, let's move on to talking about sockets. Oh, I posted an announcement, but Tuesday's class is going to be an open lab. So you don't need to come to class unless you want to, work on your code or ask questions or screen share code or things like that. I'm not going to do a regular lecture on Tuesday because Monday is a holiday and I'm keeping the two sections in step with one another. So Tuesday's class is optional. Come in. If you want help with your programming assignment in particular, that's a great time to do it. And that's going to be in my regular office hours Zoom room, not in this classroom, because I want people from the other section to be able to come in also, and they don't have Zoom access to this meeting. So Tuesday's class will be in the office hours Zoom, and it's optional, but come by if you want to work on code and stuff, and all of that is in the announcement posted on Canvas. The other yeah, go ahead.
Could we ask non-code related, more college related questions there?
Sure.
Potentially?
Yeah.
Okay, cool.
No problem.
And this isn't like office hours, right? Where it's like one-on-one. This is going to be like a classroom setup.
Well, it'll be a classroom setup, but if somebody wants to go through their code in particular, we can go into a. Well, no. So this is my Zoom office, so I can let people in when they come in. There'll still be a waiting room, but if people are just wanting to hang out, that's fine. If somebody wants to screen share, or talk one-on-one, I can open a breakout room and we can hop into there. So we can do whatever works. The other announcement is, I had said previously, the last class of the term I was going to have to cut short because of a training thing I had to go to. And we tried to have them open an extra training session, and they were like, no, we can't do that. Well, they decided they can do it, so I'm doing my training tomorrow. So the last class will not be cut short. So just forget everything that was said about that a few weeks ago. So that's business as usual. All right, let's review briefly this idea of client-server communications. We have a server, which is sort of the place to which clients try to connect. And these connection points are called sockets. There's a special kind of socket for a server called a server socket. And this has a particular port number associated with it. And these don't have to be on the same machine. They can be different machines that are connected through a network. And so there's an address, which we call an IP address. We think of it typically as a 4-part address, but it might be 6 parts now. And so the client can say, hey, I want to connect to a socket at a given IP address with a given port number, and that identifies possibly 1, possibly 0 unique server sockets on that machine. And once you make a connection, you get this two-way conduit that you can use to share information. So what we did last time was we wrote some Java code to develop this side of communication to set up a server socket. And we connected to it with telnet. We used telnet as our client just because, you know, that was handy. So I want to go back and redevelop that that server side and then add on a client side. And they're going to look very, very similar to each other. The client side is slightly easier than the server side. So let me make a class called server. And so we need to create a server socket. And naming is going to help us here. We're going to start trying to be really good about how we choose our names, because when you do two sides of communication, there's always a question of what is this relative to. So if you say send, well, if I'm talking to you, send means I'm talking. If you're talking to me, when you say send, it means I'm listening. So we're going to try to adopt good names, and that may sound silly, but it turned out to be one of the keys to making this stuff work when I was learning it versus, you know, going back and trying and getting errors and so on. So so we're going to call our server socket server socket. And we're going to create a server socket on port 1234. So we'll make a socket that will listen for connections. And then if somebody tries to connect to us, right, if a client says, hey, talk to this IP address, this port number 1234, this call to accept will return. Otherwise, we're going to sit inside this call forever until we Control C or somebody tries to connect to us. And so the server socket, we've looked at this documentation before, the accept method actually returns an object of type socket. So accept doesn't take any arguments, says a new socket is created, and that's what gets returned to us. So here's the setup. We're going to say, hey, on this particular machine, I want to connect to port 1234. If there's code running here which says accept that connection, it creates a new socket, and that new socket is connected to the client. And when the client sends something, it doesn't go to this original server socket, it goes to this new socket that's been created. And then if a second client says, hey, I want to talk to port 1234 also, the server will create another socket, and that new socket will be connected to the new client. So we have these conduits being created by the accept call, and the server socket remains, you know, diligently available. If we go back and we say accept again, it will listen for a new connection. So this new socket on the server side, that's the return argument from the accept method. So we want to say something like this. So I'm going to make a socket called client, and this is the socket that is connected to the client. And here I'm going to say client equals server socket dot accept. All right, now we're going to do the two things we did last time. We're going to create a print writer for sending to the client, and we're going to create a scanner for reading from the client. So we'll construct those here, and then eventually this is all going to go in a try-catch block. So let's say create a scanner for writing to the client. So our scanner print writer. Our print writer I'm going to call to client. And my scanner I'm going to call from client. This is for reading from the client. This is for writing to the client. So create a print writer for writing to the client. So I'm just going to say to client equals new print writer. And then the name of the socket that we're trying to write to is client. And sockets come with a method called getOutputStream. And we can use that as an argument to the constructor for a print writer. So to client is new print writer client.getOutputStream, and then and a scanner for reading from the client. So from client equals new scanner, and here's the socket name, and then we can use the getInputStream. To get the input stream we can use as the argument to the scanner. And so this is where the confusion can come from, right? I'm trying to write to a print writer, but I'm using an output stream for that. Well, output stream sounds like, you know, something that's outputting, but this is in some sense inputting because we're feeding things into it. But it's really an output system because it's producing output into the socket. That's meant to be confusing. So use good names. All right. Now all of this has to go inside a try-catch.
Is anything that any kind of method or function that has a throws on it, so throws IO exception, throws file not found exception, you have to handle when it says throws, right?
So yeah, any method that is described as being able to throw an exception, you have to deal with that, and there's two ways to deal with it. One is to call that method inside a try-catch block. The other is to call it from a method that itself is declared to be able to throw an exception. So I could put this inside a method, and that method I could say at the end of the declaration throws exception or some type of exception. And then the compiler will be fine with, okay, you don't have to catch this because you've already said this block of code can throw an exception. But then whatever calls that block of code would have to be declared as you know, inside a try-catch or something. So I think you can probably get away with putting a throws exception on here and never have to do a try-catch. And if you do that, it's going to go really badly for you. So I'm not going to type that in here and try it. But that would be the quick and dirty way if you didn't want to deal with, you know, try. If you're just doing something to get it working, that's a fast way to do it.
That clears up some confusion for me.
Okay.
I was mystified how you didn't need to handle all exceptions, but some of them you did.
Yeah, and that is kind of mystical. Like, you know, you don't have to put every division inside a try block in case you divide by 0. But I don't understand how that distinction is made as to which ones have to be caught and which ones we can just allow to go. All right, and you can also throw an exception. There's a throw keyword that you can use to say, hey, I want to generate an exception, and you can do that inside your code if you want to mark that something unexpected happened.
talk about singletons, maybe?
I don't know what singletons are.
Like a singleton design pattern, so it's kind of like a global, but you can only ever instantiate one instantiation of a specific class.
Interesting.
So like, for instance, a lot of them come up when you're talking about like network managers and lobbies or some global state that you want everything to access. So like, for example, when I'm building some video games in Godot, I usually make a singleton network manager class that only ever gets instantiated once, but everybody can access that network manager. I was wondering if maybe we're going to talk about it in Java.
Almost certainly not, because this is the first I've heard of this or thought about this. Almost sounds like something you could do with like a static class or something, or a class where everything inside it was static, and so there'd only be, you know, one version of it in some sense because it's never actually constructed. You just kind of use it from the class definition itself. But yeah, so that's not something I can talk about.
Okay.
All right, so we're gonna try to do all of this setup, construct our server socket, accept a connection, create the communication objects, the print writer for sending, the scanner for reading, and if all of that works, connection should be all set up. So so let's do. I think we did a square root server before, so let's do something different. So let's say while from client as next line. And let's just send a message back to the client. So let's just tell the client how many words they sent in that message. So this is going to be a chance to use this split function that I mentioned in PA5 as a sometimes useful way of parsing a string. So let's say string pieces equals from client dot next line dot split. Let's read a line and let's break it into pieces. So the split method is part of the string class, right? From client next line returns a string, and string objects have a split method, and you can specify a delimiter, and this will split the string into pieces that are separated by that delimiter, and it will return an array. So this is going to give us back an array called pieces. And the elements of that array will be each word from the input string. So for example, pieces 0 will be the first word, pieces 1 will be the second word, and so on. And so pieces.length will be the number of words that we had on that line. So let's just send that back to the client just for kicks. So we can say to client dot print line number of words is, and we'll just send back pieces dot length. And again, this is not a method. This is a property of this object. So we don't put parentheses after it. We're not calling a function. We're reading a property, and arrays have this property called length that says how many elements are in the array. And then we'll go ahead and flush the array, flush the print writer, and we'll go back and we'll wait for more input. And here the client has exited. And so that'll be the end of our code. And let's just throw a few more diagnostic statements in here. So we'll say waiting for a connection. And once we receive a connection, we'll print a message and see what that connection looks like. So we'll use the toString property on this socket, and then we'll construct the two ways to read and write, and then we'll just go into this loop. All right, so let's see how we did. Last line I typed had a typo. That's pretty good. Second to the last line I typed also had a typo. There we go. Now we got 8 errors. All right. So what's the small but significant issue here?
Yeah, you forgot to import.
I forgot a whole bunch of imports. So so we'll do Java util scanner, we'll do Java IO print writer. And we'll do Java net.server socket and Java net socket. And this should just be string. Alright, so we're good to go. Let's go ahead and run this. So I can use telnet to connect to my local machine, port 1234. It received a connection from port 6202, and I can say this is a test. And it tells me back that line had 4 words on it. And so on and so forth. Now if I hit Control D in my telnet, if I do end a file, which is, Control right bracket and a quit, then my server says, okay, client has exited. If I try to telnet without the server, it'll refuse the connection. If I try to run the server twice, I'll get an error and it says address already in use, bind failed. So this happened when I tried to construct a server socket with port 1234 because one already exists. So if everything goes according to plan, and then I can exit out of this. All right, so that was the server side. We set that up before. Let's do the client side. So client, we're not going to need the server socket. We're just creating a plain socket, right? So there's a parallel here, right? On the server side, the server socket is how we get the socket. On the client side, we're just going to construct the socket directly. But when we construct the socket, we're going to have to specify the IP address and the port number so that it knows where the server is located. So the constructor will be on the socket itself. So our socket, I'm going to call it server, This is a socket that is connected to the server. Print writer is going to be to server. And the scanner is going to be from server. And so here I'm going to construct a socket. So I'm going to say server equals new socket. And if we check the documentation on a socket, one way to construct that is to pass a name of a host and an integer port number. Now I can construct an inet address object which would contain, the pieces 192, 168, etc. But I'm just going to use the name of a machine and then a port number. And this can throw all kinds of exceptions. Alright, so I'm going to use localhost and then port number 1234. So this connects to the server on this machine. So we'll say trying to connect to server, we'll construct the socket, we'll say connection established. So this comes back once the server side accepts the connection. And then we're not going to do an accept because we're the client. So create a print writer for writing to the server and reading from the server. So to server equals new print writer server.getOutputStream. So remember, server is a socket. Sockets have a getOutputStream method that gives us something that we can write into that will push something into the socket. And a scanner for reading from the server. So from server is a new scanner on server's getInputStream. And the connection should be all set up now. Alright, so what should we do here? We're going to do something like telnet. So we're going to read a line from the user and send it to the server. Then read from the server. And display that line that you read. Alright, so I'm going to need a way to read from standard in. So I'm going to make a scanner object called standard in, which is a new scanner. And so we can read user input from here. And so while standard in has another line, alright, so I'm going to do this one in pieces instead of putting it all together in one big long Java string. So we're going to say standard into the next line. That's going to return a string. That's the next line from the user. And then we're just going to say to server.println line. And then to server.flush. And then we're going to read the response from the server. And so we can say something like string num words equals from server.nextLine. And then let's just see what that response was. We'll just say server replied, and we'll print out that string that we got back from the server. And then we'll go back and get another line from the user. Once the user exits by hitting Control D, we'll just say goodbye. And we will exit our main. That will close all of our connections, and that should shut down the networked connection. So let me just add one more thing in here, which is a prompt. And so down here at the bottom of the loop, I'll ask you for another line. Alright, so let's see what this does. So we'll run the server code in this window. And we'll go ahead and we'll run our client code in this window. So it said trying to connect to server, connection established, and on the server side it said, hey, I've received a connection, right? And so now my client is saying, type in a line of words. So I can say, hello, this is a test. And server replied, number of words is 5. So this is a totally self-contained client-server pair written in Java, right? You can put this on any machine that runs Java. Theoretically, this will work. And this could be running on a totally different system. And in the code, instead of saying use localhost when we create the socket, we could put in, the name of another machine. And this would still work exactly the same way. Whatever we type over here would get sent through the socket. The server will receive it, do its processing, send back some information. We get that new information over here. All right, questions? And then when I Control D over here, that exits my while loop. My main program on the client side exits. That shuts down its end of the connections, and the server detects that. And it says client has exited, and now the server exits. So this code is not, something you can just kind of take and plunk into PA5. And I feel like in PA4 there was a temptation to take some of the code we had done in class and try to build PA4 around that. And some of the code that we did in class had nothing to do with PA4 in any kind of direct way. We were talking about different ways to paint and different ways to create things in Swing and lots of example code and so on. And there's a tendency sometimes to try to, if you're having trouble getting something together, to try to just take all the things we've talked about and put them together into something resembling what you're after. And so don't do that with this, right? This is not, necessarily part of PA5. You're not going to be counting words and strings that are passed from a client and so on and so forth. But there are, the things that you'll need to do in PA5 are very close to some of the things happening in here. For example, your server is going to need to create a server socket on port 1234. And you could do it, exactly like this, inside a try statement like this. And you're going to want to receive a connection from a client, and you might do it exactly like this, right? But the disclaimer is, right, I do not intend that this is what PA5 will look like, or that you'll have a block of code in PA5 that looks like all of this. But you are free, welcome, and encouraged to, take this as a template for how you do things like construct a server socket, or connect to a server socket, or create, print writer scanner pair for exchanging information through a socket. You're welcome to take this and build from it, or use it as an example and write some code to try different ways of doing things and so on. And you do not need anything more than this for PA5 as far as networking goes, right? This is as far as you have to go. So if you're on Stack Overflow and you're seeing all these other methods you can call for sockets and server socket objects and so on, right? You're probably making life harder on yourself. Really, all you need to do, server side, construct a server socket, accept a connection. Client side, construct a socket that's connected to the server. And then on either of those sides, construct a print writer scanner pair. To read, just do the has next line and the next line. To write, do the print line and a flush. And the flush is super duper critical. All right, so questions about any of that? All right,
I
well.
think it's going to be a lot to digest, but it seems pretty straightforward.
Mm-hmm. That's fair. And I'm always suggesting this, but there's a reason I'm always suggesting it, right? Whenever we do something in class, right, go off and try it, play with it, work with it. We've got code here, right? It's posted on the server, so you can download it and compile it and run it and test it. And if you want to figure out what the telnet thing is, right, you can just run the server code and do a telnet over here, and you can watch me do it, right? But doing it yourself is different. It's more meaningful somehow when you're actually moving your fingers and typing and seeing the results of that. It somehow codes differently in our brains in most cases, and it's part of learning. And then take this code and modify it. Go back to the square root server that we did the other day, or a shout server that takes a line and uppercases it, or whatever, but if you can get comfortable with this basic setup, the initialization, and then something like this for your basic processing loop, then PA5, right, is well, I have to add this other layer on top, but if you know how to add that layer, it's not that much work. All right. And cool, yeah, that sounds good. I'll be interested to see what that looks like when you're done. Someone's saying they'll probably try to do a singleton for their network manager for PA5. So that sounds good.
It could be, you probably just call it something else, because everybody's got a little bit different terminology.
Right? Yeah. All right. So yeah, mess around with this, right? Take code we do in class and start working with it and make it your own. And if it's internalized, the more it's internalized, the more comfortable you are with it, the more you can use it to do other things. And PA5 is about, trying to make a networked dots game. It's not about trying to make a client server pair per se. You want a game that two people can play across the network. And the client server business is just sort of the tool set we're doing to enable that.
And can I ask, just to be fair?
Yeah.
When you say across the network, you mean within the same network, right? Within the same IP, or same like router setup, basically.
So when I test this, it's going to be one machine, right? So I'm always going to say localhost. So it's strictly, within one machine, two processes. But if you had another machine on your local network, you could absolutely run the client on one side, the server on another machine, and they could talk to each other. And you just have to specify the IP address of the server machine. And
it's always going to be a local server, not something like I could send to a friend in California and play with him.
well, you could though, right? If you knew the IP address of their router, and if they turned on a port forward for port 1234 to go to one of the machines on their local net, and then on that machine they ran the server, and you ran the client on yours, yeah, you could play, with someone in California. Exact same code. And you don't have to do anything extra, right? As long as you can put in their IP address. As long as their IP address went here instead of localhost, it will just work, which is pretty awesome.
Is there like a bind to any here, or any IP address? I forget what it's called, but there's something like this in C# where you could do a bind to any IP address and it will just find one for you. I don't know how it works.
That sounds pretty bizarre. Like connect to port 1234 on any machine out there?
Well, I think you have to give it a port, but like I don't have any problems with just like setting up a Hamachi and having any IP. I don't remember how it works, but
So
something like that. Go ahead.
So incoming connections, right, as they're set up, normally can come from any IP address, and there's things you can do to restrict that, perhaps. But an outgoing connection, it's a little like, putting a letter in a mailbox with a wildcard address written on it saying deliver this to anyone with a house number of 500, right? It's not clear what the use case would be unless maybe you were in a network where there were multiple servers, and you just wanted to find some machine that had a server that was ready to accept connections, and that would be pretty useful. But I'm not sure if that's the situation that you're describing. But yeah, I don't know of a way to do that other than to do it yourself by doing a for loop or something.
We're gonna do like an input where you put in the IP, right?
Mm-hmm.
Okay, gotcha.
Yeah, so I should have brought this up in the beginning. So when you run your program, right, one of the requirements is this pair of radio buttons, and if you click the server button, all you get is a start option and a name for the player. So you put in your name and you hit start, and when you do that, that's when your code will construct the server socket and say accept, wait for a connection. But if you click the radio button that says client, your button is labeled connect, you have a box for the player name, but you also have a box for a host name. And you can put in, localhost, which is the default, or I could type, 192.168.0.1, or I could type linux.engrcs.com or whatever. And when I hit connect, that's when it's going to do this construction of a socket. This is going to be, instead of localhost, whatever this field name is, .getText. And the port will always be 1234, that's hardwired. And the connect button will say go ahead and construct the socket using that field. And then the rest just kind of works.
So realistically, we should be able to just add a single class and a couple, obviously a couple radio buttons and whatnot, and that should suffice for PA5, right?
Yeah, so it's one additional class probably, which is this network piece, and it's really an add-on to PA4 with possibly a little bit of restructuring of PA4. And you can test this as you go. So if I make this the server side, and I say my name is Nick, and I say start, this has created a server socket on port 1234, and it's waiting for a connection. So I can take this client code that I had. This client code just reads a line from me and tells me what the response is. And so if I say Java client, it's going to connect to port 1234. And so it wants me to enter something, and I can say hello. Oh, never mind that. Let's do that again. So I'm hacking my net.game, game, right? So I can construct. So I can say n hello, and my game magically thinks player 2's name is hello, right? Why does it think that? Because the way that this game is written, it's designed that once you start a connection with a client, the first thing you do is you send your name. So the letter N followed by a name, and then you receive a line which is the letter N followed by the name of the other player. And what the server mode does is it takes that line, it ignores the N, it makes sure it's there, otherwise it throws an error. It takes the thing after the N and it says that's the name of player 2.
And what is the N representing?
N that's just a tag that I used in my code to say, hey, first thing you should get is a letter N followed by a space followed by the name of the player. In case someone tries to hack my net dot, like I did a moment ago, my code will throw up, right? And we're gonna take a break in a minute, and we're gonna go through some pseudocode in a fair amount of detail, and talk about a messaging protocol we can use to swap information between the client and the server. And so we'll talk about the N and the C and the Q.
Are you going to talk about serialization and JSONs?
No, we are not. Well, that would be fun. All right.
That's what I think I'll do.
Yeah? Cool.
With the game state and serialization.
So that would be a great exercise, and that would be a really good general way to do this. The way I'm going to describe it, the way we've talked about it a little bit before, and the way we're going to go through today, eliminates the need for that. And if you want to do that, definitely do it, because that would be a cool exercise for something much more general purpose and more powerful, frankly. But the way this is set up in PA5 is specifically geared to make it very, very easy to swap information and keep the two games in sync and the game states and all of that kind of stuff. And we'll talk about that after a break. But it is, kind of cherry picked as something that works in this particular setup, but it's not very general purpose. So yeah, that would be a cool way to do it. All right, well, let's go ahead and take a break, and let's come back at 13:56, and we will we'll start applying all of this to PA5. And then once we're done with that, we got any questions addressed, we'll go ahead and look at other aspects of networked communication and see what those things entail. All right, so we'll be back in about 5 minutes. All right, we're good to go. So let's talk about PA5. And I want to kind of sketch out some pseudocode based on how I think most people have done PA4. And so the setup goes something like this. PA4, so we'll just call this dots. You do some initialization. And there's various things that happen in there. And then your program, your main method, exits basically. You've constructed your JFrame and that's made your panel and so on and so forth. And then your main method just ends. And your code, is basically done. But there's an event listener hanging out in the background. And so nothing happens until there's a mouse click. And so, when the mouse is clicked, what do? Well, you get the XY coordinates. So your mouse listener has a mouse event argument. It's typically called E. And E has get X and get Y methods. So we get these XY coordinates. And then we do a series of steps. So, calculate row and column from the XY coordinates. Find the nearest edge of the box. See if taken. And if it's already taken, then we just don't do anything, or we yell at the user or something, right? Assuming it's not taken, set a Boolean. Booleans, if you have a neighboring box, if you complete the top of one box, you're completing the bottom of the box above you. So set your Boolean or Booleans accordingly. Check for a box completion. And possibly update scores. And possibly change players. So if a box gets completed, we'll update the score. If not, we'll go ahead and we'll change whose turn it is. And then we call repaint, which says, okay, paint method, go ahead and using, the new Booleans that we've set up and maybe some new initials in our box completion, go ahead and redraw the board. And then we return. And we're done. So that's a super simplified view of PA4. Do some initialization and then just respond to mouse clicks by doing these things. So let me make one change to PA4. A possible change. Maybe you've already done this. But I'm going to do exactly the same thing. Okay, but what I'm going to do is I'm going to take all of this and I'm going to put this into a separate method. And this method is called process click parentheses x comma y. And process click, calculates row column, finds the nearest edge, etc., etc. And when the mouse is clicked, I'm going to go ahead and I'm just going to call this method process click x comma y, and then I'm going to return. Alright, so this is exactly the same thing as what I had a minute ago. I've just taken all of this code and moved it into a separate method. And I've simplified my mouse handling code now to, effectively one line. Just call process click using the get x and get y coordinates of the mouse, and you're done. But process click will do all the things that we're used to doing. Alright, so that's the dots game. Everybody okay with that? As like, a way to look at PA4?
Yep.
Alright, so let's change this into net dot. So net dot, our initialization, includes a few extra steps. So it does the stuff that we normally do for dots. But then we also have to connect to the other player. So if we're the server, we'll make a server socket accept a connection. If we're the client, we'll construct a socket with the address and socket number of the client, and that will establish the connection. So connect to the other player's program, and then swap names. So I have to tell the other player my name, I have to find the other player's name. So these are new steps in the initialization. And then I'm going to do one more thing. I'm going to start a new thread, which I'm going to call net thread. Let's see, is there any way to do like a remote procedure call in Java? Like client clicks somewhere and it does a remote procedure call to process click with the X and Y of the server, and then the server updates the client. So you mean a remote procedure call like the client would cause a method on the server side to execute?
Yeah.
That would be cool.
That badly at the end.
Yeah, that would be cool. I don't think there's a direct way to do that, but that's in effect what's going to happen. But it's going to be really the server side waiting for a particular message from the client and then running some code. And that's what this net thread is going to do. So we're going to add one more piece onto this, which is net thread. And so all of this is going to be new. I'm not going to highlight it all. So what does the net thread do? It's going to say receive XY info from the other player. Well, how is that going to happen? In our process click, after we do a repaint, before we return, we're going to do one more thing. We're going to say send XY info to the other player. So just before we get out of processing our click, our mouse click, we're going to send the XY location of that mouse click to the other player. So there's a net thread process, and net thread does two things. It receives an XY pair from the other player, and then all it's got to do is call process click. And it just hangs out in a loop doing that forever. And so all of this is new. And that's PA5. That's the totality of it. So ignoring the initialization, because that's startup, and that's always kind of its own case. What's the basic setup here, right? When a mouse is clicked, do the same thing that we were doing in PA4, but at the very end, before we're done, send the coordinates of that mouse click to the other player through the socket. and in addition to that, have a second thread running, which does two things. It receives information from the other player in the form of an XY coordinate pair, and it passes that XY to process click. And this will be PA5. That's all you need to make it work, right? It's tricky to set up, but that's really the only changes from PA4 to PA5. Send the coordinates to the other player in response to a mouse click, and run a thread that receives mouse click information and calls process click. All right, so how does this make PA5 work? In PA4, right, the basic gameplay is somebody clicks the mouse, process click gets executed. The other player physically takes control of the mouse, clicks it somewhere, process click gets executed. The first player takes the mouse, clicks somewhere, process click gets executed. Right? The basic structure is players take turn clicking the mouse, and after each click, the XY coordinates are run through process click. And that works great for PA4 because the software is keeping track of how many clicks have happened effectively, modulo 2, and changing turns and updating the display and maybe color coding the lines if you did that, and switching whose turn it is except when a box gets completed, and updating the score and all this kind of stuff, right? All of that synchronization is inside your code that you've already written for PA4. So what happens when two people on two different machines play this version, this NetDot version? Well, let's say that I'm the server, okay? I'm going to click the mouse. It's going to draw a line somewhere. It's going to send that XY pair to the other player. The other player is client, so the only difference in the startup is its code is saying it's player 1's turn. It's not your turn to go. But this thread is always running, and it's going to receive that pair that was sent by the other player, and it's going to call process click. So the effect is player 1 clicks the mouse somewhere, player 2 calls process click with that XY coordinate. Well, that's exactly the same behavior as if player 1 had come over to your desk and clicked the mouse. It's the same result. Process click is called with that XY coordinate. And since it knows it's player 1's turn, it's going to draw a line, and it's going to if that completed a box, give it to player 1, and so on. And now player 2 clicks their mouse. Well, the XY coordinates of that are sent to player 1, and player 1 has a thread which will receive those coordinates and call process click. So what's the effect of that? Process click is called with that XY coordinate. It's exactly the same as if player 2 came over to player 1's desk, grabbed the mouse, clicked somewhere. Exactly the same as what happened in PA4. Process click gets called with that XY coordinate pair. And then, the display says player 1's turn. Why? Because it was player 2's turn, and the mouse click came in, and so now it's player 1's turn. So if you set this up right, it just works, right? It's designed to do exactly the same thing as two people sharing a mouse clicking in a single version of this program running. But every other click is being sent in, and process click is being called by this separate thread. But process click doesn't care, right? The way you wrote PA4, the first time this is called is player 1's move, the second time is player 2's move, the next time is player 1's, and so on. If a click completes a box, then the next click will be attributed to that same player. Well, same thing's going to happen here. So you do need one extra embellishment here in process click. So if it's not your turn, just get out of here. So you do need to keep track, of whose turn it is. And if I'm player 1, if I'm the server, and my, turn indicator says it's player 2's turn, actually, let me not do that here. Let me do that up here. So when a mouse is clicked, if it's not your turn, just return. Don't do anything. Don't call, process, click, and so on and so forth. So if I'm player 1, I'm the server, and my Boolean is saying it's player 2's turn, and I click the mouse, I'm just going to ignore it. Or maybe I'll put up a message saying, you know, please wait for the other player to make a move or something. But I'm not going to do any of this stuff. And so the only way process click is going to get called is by this net thread. And the only way this gets called is when the other player sends me XY coordinates. And once they've done that, their Boolean will switch to say it's player 1's turn, and if they click the mouse again, it's going to ignore it. And the only way that their process click is going to get called is when their net thread gets the XY information from me, which only happens when I click a mouse and send that XY to the other player.
Doesn't feel like a super resilient way to build this, but it'd work.
It will work, and there's a couple of aspects to this, and so not resilient in the sense that if somehow a message got lost, you're done. It's going to hang, right? But you know, barring real world realities, a couple of aspects of this. One, these two sides are moving in step with one another, right? Player 1 is going to click and send a message. Player 2 is waiting for a message. Once it receives it, it will process it, and then it will wait for a click and send a message. And at that point, player 1 is waiting for a message. So it's very much, you know, this person says, this person says, this person says, this person says, like that. There's no opportunity for well, no, that's not exactly true, actually. It's a little bit true. So there's nothing to stop somebody from modifying netdot and setting it up so that they could take multiple turns right before the other player has a chance to move. The way this is set up, if player 2 decided to send me multiple XY pairs, this would just dutifully, you know, take all of those as moves for the next click of the mouse. So it's assuming the integrity of all actors, right? It's assuming that the other side is following the exact same protocol, and it's certainly easily manipulated if we wanted to, you know, cheat. We could make a move for the other player by sending an XY pair out of turn. So it's not robust in that way.
I was gonna say that it doesn't seem like this would be super resilient if you're building something with a really complex state, as you're just exchanging X and Y here. But both the client and the server are updating their own state, and so there's not really a huge need to send the game state, I guess, because they're both going to update correctly.
That's the other aspect of this, is that the effect will be both games will stay in synchronization. They'll have exactly the same displays. They'll both know whose turn it is. They'll both know what the score is. But that's kind of coincidental, right? As in, you know, two incidents happening at the same time. Because the only thing that updates the state of the game is, you know, the position of an XY click. And so as long as both sides are seeing the same set of clicks, the updates will happen together and everything will stay synchronized.
This would probably be a huge mess if you had to do more things to synchronize, though, right?
Definitely, yeah. You'd need something. You'd need something more complex.
Interesting conversation.
Well, this gets into some philosophical topics that you don't want me to get started on, but this question of, you know, does physics actually work, or is it simply that, you know, these two things happen to be occurring at the same time because of some other, you know, third thing that's causing it? And when we think there's a cause and effect, is it possible that both of those things are effects of some other cause that's outside of our understanding, and all sorts of things like that. But this is a nice example of where that's exactly what's going on, right? It's not that, you know, updating this is causing that to be updated. We're not saying draw a line here, put an initial there. We're doing something much simpler, but the way this is set up, the appearance is, oh, you know, I draw a line here, line gets drawn over there. It's kind of cool. All right. The other thing that we want to do is we want to be able to shut down the game. So there's a quit option. So let's talk about messaging. So I'm still not going to talk about initialization yet. Let's just talk about the sending the XY info to the other player. So my suggestion in the PA5 write-up is to use some kind of network protocol to allow you to exchange information. There's a name that has to be sent. There's an XY pair that has to be sent and received. So my suggestion is when you want to send an XY pair, use the letter C followed by a space, the X coordinate, a space, the Y coordinate. So a three-piece message, and the C is just kind of a indicator to say, hey, this message contains an XY coordinate pair. And so when I say send XY info to the other pair, what do I mean? To player 2, right, or to other player dot print line parentheses quote C space close quote plus whatever the X value was plus a space plus whatever the Y value was, and then, you know, to the other player dot flush. So just print line into the print writer constructed on a socket that goes to the other player. Just print line a C followed by the X and Y integer values. And you can do that in here. You could put a method inside your net thread that you can call. You can structure that all kinds of different ways. But the effect is it's a single print line, which just causes that information to go out, followed by a flush. So sending it is pretty straightforward. It's just a print line. Receiving it, you have to do a little bit of work. So you can do, you know, something like string.
Wouldn't you have to do some sort of end of message signifier?
Since we're using a print writer, if we do a print line, it'll have a new line at the end. And with the scanner, since we're doing has next line, it will read up to a new line. So yeah, we do, but it's just a new line.
Gotcha.
So on the receive side, if we say, you know, whatever the name of the socket is from other, or whatever the name of the scanner is on the socket, from other dot next line. Well, you can do the split business that we did in our sample code. So we can say string pieces equals message dot split, and just split on a space. And so this will go into element 0, this will go into element 1, this will go into element 2. So now you can start doing some sanity checking if you want. You can check to see if pieces.length is equal to 3. And if it's not, then it's not a coordinate pair message. If it is, then you can do something like, you know, integer dot parseInt pieces bracket 1 and set x equal to that. And that's got to go into try catch because it's a parseInt and so on and so forth. But, you know, split is a nice way to break a string into pieces. Those pieces go into an array, and so you can do element with index 2, use that to get y, and so on. And if you want, you know, you could don't use not equal, but, you know, if pieces bracket 0 dot equals quote C is false, then you got a message with 3 pieces to it, but the first piece wasn't a C. But you don't really have to do that because, you know, we're assuming that this is your game playing both sides. And so if you get a message with 3 pieces, it's really going to be a C followed by an X followed by a Y. That's the only thing you could expect, except possibly a quit message. And so you could have one more addition in here, which would be a quit button. And my suggestion for quitting is just send the letter Q. So a really short message containing just the letter Q followed by a new line. And in your net thread you receive a message, and if the message is Q, then we can quit. So you do one extra check in your net thread, receive a message from the socket, check to see if it's the letter Q. If it is, quit. Otherwise, you can pretty much assume it's a C followed by an X followed by a Y. So break it into pieces, get the XY pair, and then call process click. Alright, the other piece of this is the name exchange in the setup. And my suggestion for that is when you first establish the connection, so create connection, make the print writer and the scanner, send my name, and then read one line from the socket, save that as the other person's name. Since this is going to run on both sides, what's going to happen? Each side is going to construct the connection, make the print writer and scanner. Each side is going to send their name to the other person. Each side is going to read one line from the socket, which means each of you is going to read the other person's name, save it in your notion of who the other player is, and then you go ahead and you start doing your gameplay. So this is just a one line exchange in the beginning, and that can just be, you know, send out your name. Now I chose to do it as an N followed by a name. But I was thinking, you know, future expansion. So my network protocol understands 3 types of messages: N followed by a name, which has to be in the beginning, C followed by an XY pair, and Q, which can occur anytime after the name exchange and means end the game. And then you can start having fun as you're developing this. So so if I start a server over here, maybe I'm just going to develop the server side, right? I mean, they kind of get developed together, but if things aren't working right, I can do some debugging with telnet. So I can say something like telnet localhost, and I know I'm on port 1234, and I get a message which is, you know, the name exchange coming from the server. It sent me an N followed by the word Nick. And I can send back another name, so I can say N, you know, haha. And it says, oh, player 2 is haha. And if I click somewhere in the playing field, I get a message. Well, I violated my protocol. I get my message as an X followed by an X coordinate and a Y followed by a Y coordinate. So I'm using a different protocol on this. This is an older version I wrote. But, you know, if you followed this setup, then making a mouse click would send a message C 261 159. And so now I can send an XY pair, so I can say X, you know, 301 and Y 347. And that corresponds to a click around here, and there's the new line that's been drawn, and now it's player 1's turn. And if I click somewhere over here, I get that new XY pair back here. So developing this, the way you develop this is important to what your experience is. Debug messages are a really good idea, right? My net thread is telling me as it receives a message, right, what that message is, and when I call my click code, I've got a message saying it's clicking, what's the row column, what's the distance to each edge, when am I waiting for a message from the other player, and then, you know, when I clicked, I got those coordinates, and so on and so forth. So debug messages, right, you want to try to make sure you know where you are. Don't just print XY, but, you know, put in meaningful messages. Inside servers process click, XY equals such and such, right? If you know what player you are, player 1 is always the server, player 2 is always the client. It's good to put those out in your messages. And this is all asynchronous, right? You have no control when the other player is going to click, which means you have no control over when you're going to receive this XY information. And if you can't quit, you know, you can come in here and I can say, okay, well, I'm just going to send a message Q. Well, if that works right, you know, my server received the Q and it shut down. That was great. Now I can hit the Q button on the server and see if I get a message saying Q. And if I do, then, you know, I know that part's working and so on. All right. And this net thread, right, so this is just a class you're going to create. It's going to extend a thread. And so at the end of your initialization, probably, or maybe earlier, you're going to construct an object of whatever, you know, type you call this class, and then you're going to call its start method. And in your net thread, this loop is going to be sitting inside the run method. So, you know, whatever this is, dot start. And remember, this is what makes a thread different from just running a method. When you call the start method, that method will create a new thread and then call the run method. So if you haven't played around with threads yet, go back and look at some of that sample code and mess with that. Make sure that's not a source of additional complications. So nail that down, and then you can use it in here. And it's really just one thread to do this loop.
It's a little bit different in this language where you basically make a class out of it
Mm-hmm.
and just assign it to a function.
Right, right. And we can also do threads a different way by implementing a runnable, and then we can just make a make that part of our class.
Kind of like how you would do an anonymous interface to capture the button input of the state changes in Swing.
Mm-hmm. Yeah, similar. All right. So questions on that? That may sound like a lot, but do it in pieces, right? First, modify your PA4 to put all of this into a separate method, and you know, skip the name swapping in the beginning. Just hardwire the names. Just call player 1, you know, A, and call player 2 B. Just hardwire that. Don't worry about it. Because this is the funnest part, right? Is the mouse clicking. So forget about the quit button. Forget about the Q message. Make a simplified interface that just gets, you know, one type of message, which is this XY pair. And you know, you can forget about this if it's not your turn. Return. That's only there in case somebody tries to cheat, you know, or makes a mistake. If you accidentally click when it's the other player's turn, you don't need that for this to work. You can do that later. If you're just going to, you know, honestly, like, click here and then go to the other window and click and come back to this window and click. Really, the only thing you need to start developing and testing and finalizing the two-player aspect is sending XY coordinates at the end of process click and making a separate loop that receives from the socket and calls process click.
So, in the initialization, doing the connection, all that stuff, should that be done in the constructor of netdots?
It's up to you.
Like,
It's
obviously you're gonna try to do the connection once you hit the start button.
so on the server side, you have a start button, and that will create the server socket. And on the client side, you have a connect button, and that will connect to a server that should already be running. You can assume the server is running first. If the server's not running, client will fail and program exits. That's okay. So if you do this in the constructor for the net thread, that's fine. It sort of puts, all of that functional behavior in that net thread object. But just remember that, if you want to do something like have your quit button send a queue, you've got to have a method in that net thread called, send quit message that'll send a queue, or you'd have to have access to the print writer object in that net thread and do your print writer.println queue and so on. I like this idea of doing all of that network setup in the net thread, and then just having some methods. Have a method for sending an XY pair, have a method for sending a Q button, and leave it at that.
One more talking about using your netdots program to call on that class and construct that object. I guess for this one, it's going to be a little different because, the start button would basically, if you hit the start button, then you could call on that class, create the class, try to make a connection, and then if you do, then go through your start method that you've already set up, right?
Yeah, so on the server side, right, which is where the start button is, you construct the server socket, you have to call accept, and accept will hang out until somebody, until a client connects to you. So you wouldn't want to call accept inside the start button event handler, because then your GUI will hang. So you're going to want to accept the connection from inside the net thread.
Okay.
Because that's a separate thread, and if I say in the beginning here, accept a connection, doesn't matter if it's hanging out there. That's exactly what I wanted to do, but my mouse click code from the start button will, return, and everything will keep running.
Okay, gotcha.
All right. So, yeah, that's all there is to it. It's just 90 minutes of explanation, right? It's if it sounds overwhelming, that makes sense, but it's really not that much extra work. The work is figuring out, how to make this all come together. Once you figure that out, you're going to find it's a few lines of code added on top of what you've already done. But, a lot can happen in a few lines of Java or any object-oriented language, so it's getting a clear handle on it. And, being proficient in debugging what you try to do. And this can lead to some weird things, right? If somehow things get out of sync and both sides are thinking it's the other player's turn, right, then nothing will happen, and it may just stare at you, right? So make sure that if you're the server, you're player 1. If you're the client, you're player 2. But make sure you decide, both sides understand in the beginning that it's player 1's turn, regardless of who you are. So if player 1 clicks, it'll say, yeah, it's your turn. That's fine. Player 2, it'll ignore it.
And so, in your spot where you're actually sending, receiving X and Y, if you're the server and it's your turn, and you click, it's just going to see where you're at, right? Like you don't have to send anything until the end to paint on the other player's screen.
So
how do you? Oh, go ahead.
No, go ahead.
I was just gonna say, how do you receive the other player's stuff first, or do you just? I guess that's kind of confusing for me.
No, this is another one of these things where it's not really like, I did a click and now I'm waiting for the other player. It kind of happens for free. In fact, I'm always waiting for information from the other player because this thread is always running. And even if it's my turn, if I happen to receive XY from the other player, I would take it as a mouse click. And in fact, it would become, misinterpreted as my mouse click, even though it was sent by the other person. But that's not what's going to happen, right? I'm always ready to receive an XY pair and treat that as a mouse click from the other user. But if it's the other user's turn, that's exactly what I want to have happen. And if it's not the other user's turn and they click the mouse, their code's going to say, oh, I'm going to ignore that click. The only time it's going to send information to me is if it was their turn. And in that case, that's exactly what I want to have happen. I want this XY pair that I receive to be treated as the other player's turn. And that only works if you get things started correctly. If both sides know it's player one's turn, both sides are still running this thread, both sides have something waiting to receive, but that person who's actually player one has the ability to send their click coordinates to the other player. The person who's player two does not have that option because if they click the mouse, it's going to be ignored.
Okay, so that's just a simple if statement, basically. If it's your turn,
then do all of this. If it's not, just return.
And just ignore it.
Yeah. But put a print message for debugging saying, mouse was clicked, but it's not my turn. I'm exiting.
Yep. Gotcha.
As this starts to come together, it gets to be a lot of fun. Because once you're able to sort of, reliably share information and respond to events and so on, you can already respond to events reliably because that was PA4. But as you can start sharing information and so on, then you start to realize, this is not a problem that I'm trying to solve. This is creating a set of tools that I can use, right? This is not build a fence. This is, here's a fabulous toolbox, with all these great hand tools and power tools in it, and suddenly you can imagine, all these things that you could build with these tools. That's the real goal of this, is to, sort of expose that kind of ability, and then the sky's the limit, because once you can do networked communications, I mean, that's all the stuff that's being developed today, right? That's the real power of being in a connected world. So this is good stuff usually.
It's also tricky to think about how to architect this stuff, because you can do it in a number of ways. Depending on your needs, you may need to build it differently. Like,
yeah, definitely.
If this were a video game, of any more complexity, you'd really need to synchronize structs or some kind of gameplay state.
Yeah. I mean, you would.
It's simple enough to where we don't really need to do that.
Right. And that's by design, so it's a little cherry picked, but it's the same ideas that we would use in more complex systems. If this were a first-person shooter or something, you'd need more information about where each player is moving, and things would be happening simultaneously on both sides, and it would be a lot of information to share. And chances are you would do that maybe through some kind of central server. So instead of having the games talk directly to each other, maybe you would update all that information to some central location, and maybe that central location would be the thing that updates the game state and then shares that with each of the players, particularly if you don't want people to be able to cheat.
Yeah. I remember Amazon had a big stink about it a couple of months ago, with New World being, to an extent, peer-to-peer. And some massive security flaws.
Yeah.
Follow
Mm-hmm. So yeah, let's look at what happens if we go beyond this. What happens if we have kind of a more general networked situation where we have let's say two processes or programs exchanging information with each other, but not in this nice, fairly clean, fairly ordered way of taking turns sending messages, but something more general. And this is not a concern for PA5, but it's a concern for future things down the road. So suppose we have two people. Let me call them A and B, and they want to chat with each other. They want to send messages back and forth. And so they establish some connection with each other, right? A is the server, they start first. B is the client, they connect to them. And so we could set up a protocol which might look like this. Let's get a message from standard in, send that message to B, get a message from B, print to standard out, go back up to the top. And B is going to do something very similar. It's going to start off by getting a message from A, print to standard out, and then get a message from standard in and send to A and go back up to the top. All right, so that's weird. My program's showing me the date. Yeah, question?
Yeah, I got a quick question. So, I know in our previous examples we used like while loops to keep the the information coming. Is that basically what we're doing here? We're going to use a while loop to make sure that we stay open and always receiving.
You talking about here or like PA5?
No, for like PA5.
For PA5, yeah. So like our net thread code is probably going to be sitting in a while loop with
So it should be like
option to
while whatever has next. Kind of
while this thing that has next, and then if has next fails, if it returns false, that means the network connection has been shut down. If the other side closes its socket, then our has next line will come back false. Theoretically, that shouldn't happen. If they send a queue message, we should receive that, and that will come before they actually close down their connection. But might not.
Like the close program in the top right, though.
Yeah, so if they just exit their program without sending a queue message, then our from player dot has next will return false. And so you would kick out of the while loop if you were doing a while, and you could say something like, other player has abruptly ended the game, and then you can just close down your side.
You wouldn't need to handle something on the socket. I remember that being an issue with C# sockets. If it was abruptly closed and you tried to touch it, it would be null, and then you touch a null reference.
It could be that has next line will fail, but like in our examples that we were doing, we're running server code in Java and using telnet as a client. If we just exited from the telnet side, the only effect seemed to be that the server's has next line came back false, so it detected end of file. But there may be situations where we would get an exception. It depends what we're doing. One possibility is has next line comes back true, but then at that point, no, I think it's okay. I think we're pretty safe. But try it. See if you get exceptions. I'm not planning to try to break your code in that way. I'm not going to, X out one of the sides and see if the other side handles it gracefully. I'm assuming that when one person wants to quit, they'll hit the quit button, and that'll shut things down.
Okay. I just like to defensively write my code sometimes.
Yeah, and that can take a lot of work in this case, because we are making some simplifying assumptions about well-behavedness. But yeah, this should be fine. So, person A is running this loop, person B is running this loop. This is going to work fine, right? Program A is waiting for the user to type something in. Program B is waiting for a message from the socket to person A. So I'll type something, hit return. That message will get sent to B. B will read the message, print it to standard out, and now B is waiting for the user to type something while A is waiting for a message from B. B types something, sends it to A, goes back to the top. A receives that message, shows it on my display, goes back, waits for a message from the user. And so these will move together, and this works great as long as we're taking turns. A sends a message, B sends a message, A sends a message, B sends a message. But this does not work if A wants to send 5 or 6 messages in a row, or 2 messages in a row. Because A can type in one message, hit enter, this statement executes. That message gets sent to B, this message executes. Well, now A's program is sitting here waiting for a message from B. And if the person running program A starts typing messages and hitting enter again and again and again, none of those messages are going to get sent. Because we're not in this part of our code, we're in this part. And we're waiting for something to come in from the socket, and if player B has fallen asleep, right, we're not going to get past this line of code until, tomorrow morning. And then when they send us one message, we'll get that message printed out. We'll read the first thing that user A typed, send that, and then we'll go back to waiting. And if user A types 5 messages, those will get sent only after the next 5 messages we get from B. So that's fine for PA5 because we intentionally want to take turns. But more generally, if we wanted to be able to, have each person send messages independently of one another, we would need to do something different. And so what we can do is we can modify this. So this is where erasers are good. I got these giant pencils. They're like beginner pencils. And they're like huge compared to like regular pencils. And I ordered a batch of pencils from Amazon and they showed up. And it was like this big box of these giant pencils. And I was like, what the heck? And it turned out I'd like bought school supplies for a school back east through Amazon, and it was a list, and so I just hit this box, and I guess it was an elementary school, and so they got beginner's pencils. So when I went to order pencils from Amazon, the first one that popped up was the ones I had ordered before, and I'm like, yeah, I'll get those. So that's why I have these beginner's pencils, but they're actually really fun to write with. There's something about like, a big piece of wood that's kind of fun.
It's funny how they make beginner pencils for kids that have small hands.
I know, right? I don't know what the logic is.
Should be like crayon sized,
Yeah. But I mean, I've had multiple people I've shown this to, and they're like, oh, that's terrible, until they use it, and then they're like, oh. All right, so here's what we can do. Program A, we can break this into 2 threads. So we can have one thread which reads from standard in, sends to the other person, and goes back and waits for another message. And then a second thread which reads from process B, prints to standard out, and goes back up and waits for another message. And if we just make that one change, this will work beautifully. Now we have the ability for asynchronous communication. Every time the person A types a message and hits enter, that message gets sent to person B. And this thread, each time a message comes in from A, it will print that to standard out. And so even if person B has fallen asleep and never hits enter, and this thread is waiting right here, if A keeps sending messages, they, write their life story and send it over to B. When B wakes up in the morning, standard out has all of those messages sitting on them. And so this is how you would normally do, kind of a two-way communication program where you don't have synchronization of taking turns sending and receiving. And that's a great application of threads. And we sort of alluded to that when we talked about threads a few weeks ago for the first time. And so this looks kind of like, process A. Well, the first thing it does is create a new thread. And then one thread is basically responsible for going from standard into B, and the other thread is responsible for going from B to standard out. And so in this case, we'd have two threads running on A and two threads running on B.
So is this how your basic instant messenger was set up back
Yeah.
in the day?
So in past versions of 223, I've had students do this for their final project, set up a chat program, and it basically ends up being like an IM program.
I could have turned in my C# version, and you maybe would never have noticed.
Yeah, how quickly would it take to notice that it's C# instead of Java?
Probably instantly.
Probably instantly. So if you wanted to do something like this, right, it's great for two people who want to talk, provided that one person is going to be the server and they're going to run first, so that B can connect to them and so on and so forth. But a more common situation would be where you have something like a central server. And if two people want to talk, they would both communicate with the server, and the server would set up a pair of sockets they could use to talk to one another. And then while they're talking, another two people could come along and talk to the server and say, hey, we want to talk to each other. Or, we could have one person who can talk to multiple people this way, and so on and so forth. And so this is a question of serving multiple clients, and this is going to be another application of threads. So suppose you have a square root server. I think we did that example in Tuesday's class, where you can send a number to the server and it sends back the square root, right? Or whatever, print server or web server, whatever. So you've got a server and you've got a client. One wants to connect to the server. So the server, does some initialization to make a server socket, and then it accepts a connection. This is pseudocode because sockets don't have has next line methods, but construct a scanner and use the scanner's has next line, all of that stuff. So pseudocode, right? Accept a connection while there has another line, do some stuff. And then if we wanted to be able to continue and accept another connection, right, we could go back up to the top and say accept another connection. So this would be a server that could, wouldn't just go away once the client exits. And the server client examples we've done, we run a server, we will run a client, they do something with each other. When the client exits, the server exits. But, in practice, the server should persist. It should survive the client. So we could put a loop at the bottom to say go back and accept a new connection. And then somebody else tries to connect. It comes back from the accept call. It does its exchange with that client. And when that client exits, it goes back and takes another connection. So this works great as long as you want to deal with one client at a time. But if you wanted to handle multiple clients, you can use a thread for that. So we could do something like this. Do some initialization. And then we could say, server socket.accept. get a connection to a client. And then we could say make a new thread which handles the client. But meanwhile, we go back up and we say accept another connection. So as soon as we accept a connection, we make a new thread. We give that thread the information it needs to talk to that client, and our server goes back and says, hey, accept another connection. And some other client comes along and says, hey, I want to calculate some square roots. It makes another thread and does whatever it has to do to handle that client, and meanwhile the server is back to waiting for another connection. And this is the more typical setup for a server in an operating system, for example. A web server or an SSH server, right? If I want to telnet or SSH into the Linux machine, I contact the SSH server, SSHD, and it creates a new thread to handle my login. And so while I'm talking to, the Linux machine, somebody else can come along and talk to the server and say, hey, I want to start a connection too. And the server will, create a new thread to handle that connection, and so on and so forth. And so that's usually how server side would be set up. What's the danger here? If I were to put this code into the Linux server and start running it, what's the potential?
You have like 1,000 people trying to connect at once.
Yeah.
You may not have 1,000 threads to spare.
Yeah, the way I've got this pseudo-coded right now, if somebody were to just write a program in a loop that continually tries to make connections to the server, this is going to accept each one of those connections and create a new thread. This is going to run out of threads. And if your JVM runs out of threads, it's probably going to crash.
There's still like a thread pool that's probably going to manage all that, and 1,000 may not kill it, but 1,000,000 or more, yeah.
Yeah, if I put this in an infinite loop trying to connect, I will at the very least degrade the performance. If it doesn't crash, I may end up with 10,000 threads doing something. And if this is like a chat program, I can start sending them lots of messages, and they'll be doing lots of work, lots of CPU bound work to construct responses and so on. And you can do a denial of service attack very easily on something set up like this. And so you might want to do something like T count. Keep track of how many threads you have. And then if T count is less than or equal to 10, go ahead and accept another connection and make a new thread. Otherwise, just wait for the thread count to go down.
Maybe queue up the last requests.
So there's a separate queue that's set up in the server socket that will queue incoming connection requests, and we can set that up in the constructor actually, and it defaults to I think 50. So if we only wanted 10 threads, we could actually handle a backlog of 40 connection requests, and that would be handled by the server socket. But this starts to get tricky, right? If we decide to manage threads like this, we could set the thread count to 0, and if it's not bigger than 10, we'll go ahead and accept the connection and increment T count to say, hey, we've got another thread, make that thread to handle the client, and go on and so forth. But we need a way to bring that thread count down, right? We need to know when this thread is done. And so maybe we could do something in this client that says, decrement the thread count before you return. And so now if we have 10 threads running, we won't accept any more connections. But then if one of the clients finishes, it will decrement thread count to 9, and this will say, okay, next time we get a connection request, hey, we've only got 9 threads. Yeah, we can go ahead and accept. What's the potential problem with this? If we're going to have 10 separate threads, any of which might try to modify this thread count, we need to synchronize that. Because, decrementing is a read, modify, write. And what happens if 2 threads simultaneously try to decrement thread count, and we get into that Yoda Darth Vader issue from a few weeks ago, where one of these obliterates the effect of the other? And 2 threads try to decrement thread count, it may be that thread count only gets decremented by 1. And this could happen if, for example, some chunk of the network goes down. We've got 50,000 clients we're talking to who all suddenly terminate because, something in a trunk back east failed. And so 50,000 of our threads need to decrement the thread count at the same moment. They're going to conflict with each other unless we synchronize. And our thread count up here may not go down by 50,000. It may go down by 10,000. And what does that mean? It means that we're going to think we have, X number of threads when in fact we have fewer than X threads. We may think we have 5 threads running, but in fact we've only got 1. And if we're not accepting any more threads when this gets above 10, we're limiting ourselves to 6 threads now instead of 10. And the longer this runs, if this runs for days and weeks and months, the worse this problem will get. And we're never going to see a compile error. We're never going to see a runtime error. This is a difficult to predict occurrence that may happen once in a while. But if this server is up for a long time, a few months, we may find the performance degrading, and eventually somebody may start looking at connection requests and what's accepted and what's rejected and say, hey, we're rejecting connections even though we've only got 3 threads running. And the effect on the customer is, this server is more and more saying that it can't accept our connection, that it's busy, but it's doing it in the middle of the night, and it's doing it on the weekend when it should be underutilized, right? And this is one of these bugaboos from sharing resources across threads. And it's easy to fix, right? We just put a synchronize keyword around these modifications to make sure that only one thread is modifying this object at a time, and problem solved. But if you don't know that, right, this can be one of these bugs that just sort of gradually creeps up in severity and can be really hard to find. So if you extend NetDots to let like 1 million people play the same game, this would be a concern maybe. Yeah, question or comment?
I bet you could very easily make it so that NetDot has like 4 players all on the same board, and still, there's really no reason in the game to just restrict it to 2 people.
You should be able to. So PA4, how would you modify it to allow multiple people?
It'd be a little tricky depending on how you built it, but you'd have to make the turn switching go through the all of the players. You would have to instantiate some more scoreboards. You'd have to make sure you're keeping track of the state of all the players, and
I think it'd be pretty easy. Instead of using a boolean, just use some kind of a 1 through 4 or something like that.
Yeah.
As it gets to 4, next turn goes back to 1.
Yeah. So you could use an integer for the player turn. You could go from 0 to n-1, just use a modulo or roll it over by hand. And you need to know the name of each player, But when you set an initial inside the box object, you take, player name, bracket, player turn, first character of that, and the rest of it probably works. And then for the networked version, I'm not sure it changes a whole lot. I mean, if you had player 4 set up for multiplayer, I think it's probably the same.
It would probably be very handy to have some sort of network manager acting as like a lobby for the server to make sure to update every player's state, and also so that maybe you only want to play with 2 players, or maybe you only want to play with 3 players. It's built to withstand all that stuff.
Definitely. Yeah, so you could do a lot with this. Cool. All right. Well, we're at 3:11, so I should let you go. Let's see. Office hours tomorrow morning. Monday is a holiday, so no classes at Clark. And then Tuesday I've got regular office hours, and we'll have open lab during class time in my Zoom office instead of in the 223 Zoom room. And then Wednesday, Thursday morning office hours, and then I'll see you Thursday. I won't see you in class. I won't be lecturing in this class until a week from now, but I'll see you Tuesday if you want to come in for open lab. Come into the office hours Zoom room. Either way, hope everybody has an excellent weekend, and good luck with your coding here and your other classwork. Take care, and I'll see everybody next time. All right, thanks.
Thank you. Take care.
You too.
Have a great weekend.
Thanks.
Have a good weekend.
All right, you too.
Thank you.
Yep.